Serious?
Yeah, I think so. So we don't usually do this, but we skipped all the machine work.
Right.
On this video.
There wasn't a lot of machine work, a little bit, to get where we're at. We just finished up that 351 Windsor. That, again, wasn't much machine work. Is an engine that had just been done. Customer had problems getting it started and ended up kind of ruining the engine, so we did it over. And we've got another one here similar to this, 350 Chevy, out of a 87 pickup, flat tappet cam. This is an engine that we did, I don't know, 4 or 5 years ago. They were kind of restoring this truck. Basically got the engine in, got it running, didn't drive it. It went straight to the body shop, in and out of the body shop, moving around the body shop, start and stop, start and stop, start and stop, and next thing you know, the cam's flat. Which I know flat tappet cams are getting a bad rap these days, but I think it mostly has to do with the fact that it was just all start and stop. Just go ahead and put a little bit down.
You want even on the lobes right now?
I guess I could go ahead and go in without. That's enough for now. I gotta have something to hang on to. Anyway, cam went flat, pretty much ruined the engine, all the metal through the bearings, but there was some funny stuff that went on with it when it was at the body shop. Somewhere or another, they had the throttle body intake and throttle body unit on and off of it at the body shop. I never did get the full story of why the body shop was messing with the engine. But regardless, cam's flat, all that metal through the bearings, scratched the piston skirts all up, scratched the cylinder walls. Okay, catch the next one here. We tore the engine down, and at this point we're going to do a conversion over to a roller cam, and we're using the roller cam that the next series of this engine uses in the WinSOR pickups 96 and newer.
So the 351 Windsor we just wrapped up, it was probably a little bit more operator error.
There was nothing wrong with the machine work.
Same thing on this
engine. The other shop did.
Except this one is ours instead of a different machine shop. But again, kind of consensus was we didn't really do anything wrong, but
they didn't do anything to help us after they got getting it started. So along with that, what we thought might make an interesting video here is this is a 60 over 350 Chevy. We just got done doing a 60 over 351 Windsor.
The Windsor got a mild flat tappet cam.
This is getting a factory fuel injected roller cam.
So we'll do a little comparison of how they run.
Kind of get the Ford guys and the Chevy guys going at each other.
Yeah.
And the Chrysler guys will probably just stand back and laugh.
Yeah.
All I did at this point is hone it again.
Yeah, oh, right.
But to clean up the scratches, it's a loose 60 over.
Yeah.
Yeah, it's going to be
Which is exactly like the Windsor was.
Yeah.
The Windsor was a loose 60 over as well.
Yeah, when we got done with it.
The Windsor, we reused the pistons. This one is getting new pistons because of the fact that
the skirts were so scratched up from all the metal that went through it.
And the pistons it's getting now, are they also for a Vortec?
Yes.
Like a WinSOR?
Yes, I went ahead and used the WinSOR Vortec piston.
So it's getting a little bit different piston than it did when it left our shop.
Yeah, it's going to be kind of a in-between motor. It's a little bit throttle body and a little bit Vortec, but it will have the throttle body back on it when we get done, when it goes back in the truck. We're going to run it here in our shop with the Phytec fuel injection, just like we did the 351 Windsor. Where are all our torque wrenches?
Couldn't tell you.
Where's the small one?
Probably wherever you put it.
Probably wherever you left it.
30 on the mains?
Yes.
So you had to grind the crank again?
Yeah, this engine's already been done a couple times before we ever got a hold of it. The first time we did this engine, I made the crank 20/20. This time it was all scratched up. I went 30/30. Now, I need to check and make sure those bolts will clear the timing gear. This block had a flat tappet cam in it from the factory, but it has been machined from the factory for a factory roller cam. But I had to gather up all the extra parts and pieces to make that happen. We have to use a different timing set, different lifters, of course the roller lifters, the dog bones, the spider tray to hold all that in place. and this uses a thrust plate on the front that I was able to obtain, but I had to come up with my own bolts, and I wasn't sure that the head on them would clear.
And they won't clearance themselves?
Well, I've heard of engines that are self-clearancing, but I've never had much luck with that. Well, that appears those clear, don't they?
Yeah.
Everything's fine. Okay, what's the deal here? There we go.
Well, you see, the deal is you have to actually put it in the bearings, not next
Not
to the
next
bearings.
to the bearings. Is that what happened?
Yeah.
Okay, put some lube on that.
So on the Windsor, it had been balanced, but we did not get a chance to double check that because we didn't want to attempt to press their
Their pistons back
pistons
off the rods
and
and mess them up.
this crankshaft, when it left our shop originally several years ago, we must not have had a balancer at the time,
We probably didn't.
Or
That was probably before we had the balancer.
or it just didn't get balanced for whatever reason. So that was some of the other machine work we did on this, is we did have to drill a couple holes because the pistons we're using are considerably lighter than the pistons that came out of it, right?
Yeah, I was surprised how much lighter the VNR pistons are than the VinK TBI motor.
Again, we didn't record any of that, partially because we got a new balancer upgrade that we'll be talking about in future videos, and we used this engine as the guinea pig somewhat. But I think we had to remove about, there goes the $6,000. Initially, we were about 30 grams on the front and 45 grams on the rear, and we got it down to under a gram on each side. 3.5 inch radius probably at the counterweight.
I was gonna say, why don't you go the right way? You got 11/16.
No, I don't.
Really? Who keeps texting me?
Smack it forward and backward to align the thrust. Keep chasing me around.
This engine stands a long ways around. Wow, look at that.
Turns good.
Okay, there you're all the way back.
Okay. Okay, so you're 3 plus. Almost. I'm gonna show the camera straight on this time.
But now,
Come take a gander. You come look too.
you want me to look?
Yeah.
But I can't see. A dot, and a dot, and those teeth almost touch each other.
They are insanely close. Huh. Why so close?
It's just the way it is. And you probably better check that, see if it has just a little bit of in play.
I'm not gonna bother putting an indicator on there because I can hear it.
So before we got to this point, I did check the end gap on my rings off camera. Since we're using the Vortec VNR pistons, I'm using the specs for ring end gap for those. It says top ring is supposed to be 9 to 15, and then the instructions with our hypereutectic pistons here want you to increase that by 40%. So that would bring you up to 13 to 21. And when I checked our end gap, we had about 19. So we're going to leave that alone just the way it is. And then it said stay with the recommended second ring end gap of 17 to 25, and I was coming out at 23. So I'm happy with my end gap. We're right in an acceptable range there. Shouldn't have any trouble. My second ring here, I'm sure you can't see it on the camera, but it says up right there. So I have to install that so that side of the ring is facing up. My top ring, there is no difference on it whatsoever, whichever way you want to go with it. So I am installing those just however they come out of the package. And just for the sake of keeping everything alike, I'm putting my top gap in line with the front arrow. So all of my top gaps will be facing front. The second gap will all be facing back. Stock resized rods, we did put new bolts in them the last time we did it. Lube the cylinders.
Start?
Go ahead and start. Get her done.
I'm like, where'd my hammer go?
Wow, that did go in nice.
Yeah. Put that one in the right way, right? Never know.
On camera.
Actually, if I'm gonna screw up, I'd rather it be on camera.
Well, it is kind of nice if things don't go quite like you thought they should. You can go back and look at what you did.
Yeah. $45?
Mm-hmm.
I've done my share of 350 rods in my day.
Kind of put yourself through college doing 350 rods. You look like an idiot.
It's going back with all the emission stuff on it.
Yeah.
It's part of why we didn't go
Why we
cam or...
Yeah, why we didn't go anything performance is because it has to go back and the factory computer has to work with it and it has to pass Colorado emissions.
You weren't sure what I was pulling out from under there. Surprise!
I was hoping you had something on under your dress.
Ready?
Yep. There it is. Yep.
Ready?
Yep.
So this one's set with a little bit of water.
Yes.
See, I see one little spot there of...
Yeah, this engine is very similar to our 351 Windsor in many ways because it had water stains in the cylinders, and so does this one.
Yeah.
But
And I've rolled until I hit the stop on this side, 34.5 that way. And again, I'll just double check. 34.5. So now I know that when we're actually at top dead center, we have true top dead center on our degree wheel here. Our specs for a WINDSOR Vortex stock cam says the intake center line should be 106. I'm gonna do the intake center line method. I'm gonna go 50 thousandths before max
50
lift,
thousandths after?
take a reading, then I'll go 50 thousandths after. And it doesn't have to be exactly 50. So I'm gonna go to about 235.
You said you don't have to be exactly 50, meaning as long as both sides.
As long as I go the same amount.
Same amount on both sides, yeah. We need to make that clear.
Okay, I put my indicator on the wrong valve, so we'll go off the exhaust center line, which should be 116 according to that catalog. Right there. That explains why we're on where we're at on the wheel. Okay. 24.5. Plus 109.5. Okay. Instead of 24.5, give me 155.5, and then 71.5.
113.5.
113.5.
Yeah.
Okay, so that's that would be 2.5 retarded. That's a full 3 degrees retarded according to that book. Not really where we want it.
No.
I'm out of time today.
Okay.
So we'll make our decision and
Well, that's it. That'll give us overnight to think about it.
lay here and think
what
about
we
it.
want to do.
Walk us through the plan.
Since we're more than 2, let's drill that, put one of those offset bushings in there, and let's shoot for 4 advanced from where it is right now. And that will get us, if anything, when we're done, we'll be a little bit advanced, not retarded. But they make these little bushings. I don't know if you can see that in my hand, but the hole is offset in there.
Okay.
And they range, there's 5 bushings, range from 0, 2, 4, 6, and 8 degrees, either advanced or retarded, depending what direction you put the bushing in when you
Okay.
go back together.
So you drill out the dowel location in the
In the sprocket,
sprocket.
and then put the bushing in as a spacer, and depending on which bushing you use and which offset, what direction you offset it, either advance or retard.
the cam
Yeah,
and use
and use the
our
stock timing set.
instead of having
Yeah.
to spend
Yeah.
big money on a
Yeah,
multi-keyway adjustable timing set.
yeah, and no reason for that on a stock engine.
Okay. I should be able to drill through and not drill into the table of the mill, but if I do, luckily somebody else has already drilled into the table of the mill, so I won't be the first guy to have done it. I've gone in and gotten ourselves aligned on the original hole, and we'll put our 13/32 drill bit in.
Where you left off there, but you enlarged this hole, the dowel pin holes there, so the offset bushing will fit. But then we also had to enlarge the 3 bolt holes so there's enough play in there to be able to make that move without hitting the edge of the bolt hole. If it's thinner here, the cam is going to be
Okay, so we're gonna check the intake center line. I don't remember which bushing we have in.
we have the 2 degree bushing in there right now.
Okay, so I'm stopping 50 thousandths shy of max lift, 63.5,
Okay,
past max lift, maybe 148.25. So add those and divide by 2.
just shy of 106,
Just shy, so like
like
105.
105.875.
Okay, so we're right on the money
Yeah,
for the center line.
yeah.
Okay, let's check the exhaust real quick. But
Okay.
we should be pretty
Just for
reasonably good.
just for the sake of verifying our work.
158.25. 73.25.
115 3/4, and we're supposed to be 116.
Okay, that'd be slightly retarded on the exhaust.
Is it?
Yeah, but whereas on the intake, on the intake you're gonna 105 something instead of 106, so you're slightly advanced there.
Okay.
We're coming out as close as you can reasonably get.
Yeah, we're within tolerance.
So I dropped a little dab of lube on the cam lobes itself. I put a little bit of assembly lube on the bores, and then I just put a drop of oil in on the roller and made sure that they were oiled a little bit. No up or down on these.
20 pounds. But that should hold all those lifters in place. So I got the a plate on the front of this. The bolt pattern diameter is a little bit smaller on the roller than the flat tappet cam. So I had to elongate the holes in that plate because we had to have that plate on there to hold that bushing back in where it belongs. But after elongating the holes, I didn't like the hex head bolts that came with this. So I'm going to put the original bolts back in because they have the washer head bolt, and it holds that plate, spans the larger opening a little bit better. I've got them Loctited. Obviously, I can't really bend the tabs over. I'm not worried about that coming loose with the Loctite on there anyway. I think we can spin this back over and just put the timing cover, and the oil pump, and the oil pan on.
You torqued those?
I torqued those.
Okay.
I put the rear seal on this morning before you came to work because I had to take the engine off the stand to be able to get at it. It took a little bit of time, so I thought no use wasting that on camera.
Our pistons came out, you said 35 to...
30 to 40 thousandths.
In the hole?
Yeah, in the hole. I do want to do just like we did on the Ford the other day and put the plate on there and actually measure that before we put the heads on.
Okay.
Yeah. I'm going to take it back in. Get our shop put it in the vise to finish driving that in.
Okay.
Because a guy can, and I have broken the pumps off trying to
do it
drive
right on there.
Bolt it on.
Okay.
Gave a little spot weld on here. Don't show that weld. It didn't come out very well. Spotted.
So that's about like every weld I've ever seen from you.
So anyway, there's a little spot of weld on there. Along with the Loctite on that screen, it should never come loose.
Is this the gasket they come with by default by this point?
Yes. Once you got to the one-piece rear main seal engines, they all used the one-piece gasket, yeah.
Before we put the heads on, we're gonna put the damper on.
And then you still
that's
got...
what I'm saying is rotating assembly, plus that heads, intake, and cam kit. You have $10,000 in parts.
Yeah.
Without us marking them up any.
And that's not bearings. You still got to do...
Yeah, you still got to get a set of bearings. I like this tool.
Is that your favorite tool in the whole shop? Well, I used that guy's cam bearing tool on this too. We didn't show that, but ready to go.
Yeah.
To pull it all the way? Must be. Yeah, that's pretty amazing. Just that quick you've got it on there. I mean, that's way better than those tools I used to have that you had to screw in there and use that thrust washer and a big nut and everything to pull the bouncer on.
3 or 4 times and the threads are stripped.
Yeah. I'd say it's awful close. The way we're trying to find top center here is not the preferred method, but we're finding what we're indicating here and what we've got there are so close, I don't think it's going to matter.
So did you actually CC the heads?
Yes. I put a little of our assembly lube around the top of the cylinder there, ran the piston to the top, wiped it clean, because that way it'll seal this so we don't get anything down around the rings. I put a little assembly lube on the deck surface there, laid the glass on there, and let's see what it takes to fill that chamber.
Okay.
19 cc's.
Assuming we have a 40 thousandths head gasket, it's coming in like 8.99 to 1.
Okay.
So,
okay.
Isn't that right at, wasn't the 351 Windsor right at 9 to 1 also?
Yeah. That's why I thought it would be fun to compare these two engines, as they are so similar.
Yeah.
put that on this side over here.
Okay.
Hold it up against there, get it on the dowel pins.
Yeah, I will.
And then I will roll it back level. That way if there is anything loose in the water jacket, it won't fall in.
Okay. Okay. So for those that don't understand why we wouldn't put the heads on right side up, if you have it sideways like that, if there did happen to be, and again, we don't make a habit of it or anything, but if there did happen to be some debris
In the water jacket, because it is next to impossible to get everything out of the water jackets.
but if there is, it'll fall, it won't fall into the cylinder when you go to put the heads on,
Right.
so.
Okay, let me go get the white sealer.
Did you put the pistons in?
Did you put them in the right way? You didn't look at the arrows on them, did you? I got you
I looked
worried.
at some of them, but I probably didn't look at all of them. $17, right?
Yes.
What, some go into water and some go into the intake ports?
Yeah, the intakes go into the intake ports and the exhausts go into water.
Okay. So we're putting them on with a healthy dose of our anaerobic sealer.
Yes.
So did you do the heads over?
I took them all apart, cleaned them up, took a stone and just barely touched the seats. I mean, they cleaned like right now. Because
Charged the customer for a full
I charged
valve job?
customer for a full valve job.
Good.
It's the way you make money. You're gonna have everybody
Yeah.
all over us.
Were these new rockers the last time?
I think they were. I was gonna go back at the invoice and take a look, but they really do look virtually brand new.
4 years ago. Guides, seats, valves, seals, keepers, springs. Huh. It does not say,
Does it say anything about rockers? Well, if they weren't new, I am kind of surprised because they are awful nice.
they look brand spanking new.
Yeah, that's what I'm wondering if we didn't get them billed out.
Didn't get them billed out, or maybe all this talk about the body shop.
Maybe they put some
they
new
were
parts
putting-
back in.
Maybe they were donating parts. They were putting new parts in.
Get it all the way on.
Okay.
I wish our engine stand didn't have them big old legs on it. Makes it hard to get up here with our new roly-poly chairs. How far are you going down?
How far should I go?
I'm going to say 3/4.
Here we are. 3/4.
Yeah. I just thought I'd run some others down a little bit closer for you.
Okay, so now I'll go through a 1/4 turn at a time
Yes.
and go through the firing order, and that should ensure that the intake and the exhaust are both on the base circle when I'm adjusting the valves. So in case the video can't tell, I'm tightening down the adjusting nut while turning the push rod. And as soon as the push rod gets tension on it, you know that you're at 0 lash, basically.
Yeah.
And then we can do our 3/4 turn. I guess I don't understand why. I mean, I get over time, like later on, if you were adjusting valves, doing it, you know, with the engine running or whatever. But I don't understand why the first build you would ever do it that way.
Maybe people think they get them just a little more accurate that way.
I'm sure the old timers will tell me in the comments why my opinion is stupid.
Well, and I'd like to hear that because once I figured out you could adjust valves like this, I don't think I have ever done them with the engine running again because it's so messy.
Yeah. It just seems like you can do it, almost everything here in the build process,
Right.
to where you can just start it and run it
And not have to worry about it.
anything until clear down the road.
Yeah. Is the camera such that you can see on that one? Show people when you come down to 0 lash that doesn't mean the plunger is bottomed out in the lifter. Because I've had plenty of customers over the years that crank them clear down to this bottomed out and then give it another, and then give it 3/4 of a turn. And that didn't work so well.
Yeah, no, I'm almost right there to where all the slack.
Yeah, because that plunger is spring-loaded in the lifter, even if there's no oil in it. And you can feel that point when you come down against it.
Well, that's the thing. If you keep going super fast, you overpower the oil, and
Yeah,
it does keep going.
Okay,
up.
hang
But
on.
right there, I'm.
and I'll bet, yeah, see, I can still
Yeah.
push that plunger down into that lifter because it's not full of oil, but it is spring-loaded
Yeah.
to where you can feel that 0 lash point.
But like,
Yeah, that's just sloppy. That needs brought way down. And you can usually, when you rotate it, you usually feel it. And show the people again that you've taken all the slack out of it. You have just a tiny bit of tension against it, and the rocker will. You can push that push rod down, compress the plunger in that lifter.
yeah.
Once we prime this and the engine starts, has oil pressure, it will pump that lifter up, and this spongy part you're seeing here right now will be gone. Let's cover up some of it here. We'll put the black paint on it, and then we've got a Edelbrock Performer intake to go on it. I would have left the original manifold, but it was getting pretty eroded and nasty looking. I was scared it would leak. So I thought, let's just put an Edelbrock on it. And where's that adapter plate?
There. We'll see how this.
We'll see how this works. And this is by no means anything I would put on there permanent, but we're going to put that adapter plate on there so we can use our EFI fuel injection on here to run it on the dyno.
See what that does.
And see what it does. Yeah, I didn't want to have to put a 4-barrel manifold on and take it back off and do that just for the dyno run. So I got this adapter plate that I'm sure we'll get all kinds of comments on, but I think it'll serve purpose for a temporary run on the dyno.
Okay. So we finally got the dyno set up here. Kind of same standard stuff like we've done on the last couple engines. Break-in oil. I mean, luckily this is a roller cam, so we don't really have to worry too much about that part of the break-in, but the break-in oil is still good for
the rings,
and such. What's our process here with it not being a flat tap?
Really just get it under load as quick as we can.
So fire it up, check the timing, and
we'll
start
fire it up,
cycling some load.
get the timing right, and go from there. How come this
What a
is
better
such a
way to
mess?
celebrate the 4th of July than a bone stock 350 Chevy, right? And burgers on the Traeger behind you.
Burgers cooking behind us. As far as I'm concerned, it's a good way to celebrate.
Yeah. Well, I guess I need to turn the ignition on and program the Phytech real quick.
Okay, get that done.
8 cylinders, 350, cam 1 or 2?
1,
Rev limit?
5,
What do you want it tidal at?
800.
Is your fuel ethanol free?
Yes.
Okay, are you ready?
I'm ready.
No fuel leaks.
Don't believe so.
Ignition. Pumps are on, water's flowing.
Got water here.
Ready?
I'm ready. That's amazing. Absolutely amazing. Somebody needs to turn the distributor. Advance it this way a little bit.
Just a little.
There. Just a little bit more. That's enough. Give it a teeny tiny bit more.
Advance?
Yeah. That's good.
What do you have it set to?
10 degrees. I just think that's incredible how a brand new engine started like that with that fuel injection on it.
Yeah. You want to just kind of gradually load it?
Yeah, bring the RPM up a little bit. Load it just a little bit. 18 inches of vacuum. 60 pounds oil pressure.
Is that okay?
Yeah. We're at temperature, okay? What do you think?
I think the burgers are about ready.
So we're gonna have to shut this down, come back after lunch?
Probably. Sounds good.
Yeah, I think the motor itself sounds fine.
I'm gonna go eat lunch.
Okay, well, let's do that, and we'll come back do some runs.
Yeah. Okay, so we had good lunch.
We had good lunch, very good lunch.
We're gonna fire this back up, and I'm gonna do a little bit messing with the EFI to get it to idle down, and then maybe we'll start doing some runs. And we were saying we don't need to do a lot. Again, the point of us putting this engine on the dyno here is just to prove it mechanically for the customer, because they're not going to be running the EFI stuff anyway.
No, well, not
this
aftermarket. It'll have a factory throttle body
Yeah.
on it.
But anyway, so maybe we'll play with the timing a little bit, but just for our own fun, do a few runs, make sure it doesn't throw a rod.
Yeah, or two.
I went back to our video from a few weeks ago of the 351 WINDSOR when we put the EFI on it, and it peaked at about 261 horsepower. the way our dyno reads. We'll have to get back up to 180.
Okay. I think that is a starter.
So we maybe have a little noise with something with the starter.
Yeah, I think the
Just in case people can hear that, because sometimes the camera picks up things that aren't as audible.
yeah. When I first put the starter on, it was the flywheel was rubbing it. The ring gear was rubbing on the, I don't know if it was on the housing of the starter or what. And I repositioned it a little bit and thought it was okay, but I can pick up this little bit of noise there.
Yeah.
When I put my ear on it. Oh, I'd do a couple of easy ones. What, maybe 3,500 or 4 to begin with. I think probably everything is okay at this point, but I'm just curious what this 350 will do, 350 Chevy compared to that 351 Ford.
So the Ford made 261 horsepower at about 4750.
Okay.
So we'll have to do a run up higher to really.
Yeah. Well, let's do a couple of easy ones
Yeah.
first, just to make sure, and then we'll take it on
Let's
up.
go 2 to 4 to start, because
Okay.
right now we also have the rev limiter set to 5,000.
Okay.
So I'll switch that over to servo. So our start RPM, that's what this knob down here is. We're starting at about 2,000. I'm going to change our upper test RPM to 4,000, or just slightly above 4,000, so that we get that
Get that last reading at
4,000
4.
reading. If you set it right to 4,000 and you're just slightly off the dial, it doesn't give you a reading at 4,000, because it only gives you readings every
250 is it?
250, I think,
Yeah.
250 RPM. We'll set our rev limiter here to 5,000 also,
Okay.
so that just kills the ignition if we hit that speed.
Okay.
And I've got it set up so we can print, and we'll have our
Okay.
file saved over there. Okay, you ready?
I'm ready.
I think it smokes the 351.
Serious?
Yeah, I think so.
Caleb is not going to be happy.
No? Because it made 216 at 4,000 there. Let's see if we can compare. I'll open up Caleb's motor. Okay, 2250 to 2250. So 312 for the 350 on the torque to 280 on the.
Wow.
So you're 30 pounds more torque, only 14 more horsepower. Where did this peak? This peaked at 2750, whereas Caleb's was peaking higher up. So this maybe it has a lower power band.
Which is what we want for this engine.
Yeah, but in that 2,000 to 4,000 run, Caleb had a max on the 351 Windsor, had a max torque of 308 pound-feet at 3750, whereas we had a max torque of 319 pound-feet, so about 11 more.
Okay.
Which isn't a crazy amount.
No.
Which we're not expecting a crazy amount, because they should be very comparable engines.
Yeah.
But ours was at 2750, so 1,000 RPM lower. And our horsepower, we have 216 at 4,000. It's still going up. And he actually had 230 at 4,000. So more power.
Okay.
So maybe ours is going to be more torquey, but not.
Okay.
The torque is going to drop off sooner, so since you're not spinning as high of RPM, you may not get as much power.
Yeah, as many horsepower out.
Yeah.
Okay.
Let's do another one, see if it.
I want to advance the timing a couple degrees. Okay, advance it just a little bit for me. Hold it. Back it off a little bit. Advance it just a little. There. That's actually too much.
Too much? Go back?
Yeah. There. You're pretty much straight on 10.
10. Okay, I hooked the vacuum back up. And every time we start a run, I lean forward and my table starts going up and down. I mean, it was almost exactly the same, but 2 pounds of torque less at 2750, which is the peak. So it actually dropped us a little bit. Although max horsepower was actually a little bit more.
Okay, let's go 2 more degrees, and that way we'll know we're either over the hump and we are making it worse, or it was just a difference in 2 runs.
Okay.
Hold it. Back up just a little.
So this is 12?
This is 12 now.
The torque dropped another pound, but again, I don't know how repeatable.
Okay.
Max power was slightly lower than.
Okay. So probably that 10 degrees,
10 is probably closer to right.
I think we go back to the 10 and
Lock it down.
lock it down, call it good.
I didn't change the test speed here.
Oh, I was gonna say, that didn't sound any different.
They're all very similar.
Okay.
Now let's try for 5,000. Okay?
So what did you change here?
I changed that to 50/20.
Okay.
So it's actually significantly less power than Caleb's was. Okay, we peaked 315 pounds at 2750.
Okay.
And we peaked power 219 at 4,500. So we're a little bit more than a TBI, but we're not what a Vortec is rated to.
Okay.
Which makes sense.
Yeah, because the Vortec has much better heads than what these are.
Yeah. But it has a lot more torque than Caleb's down low.
Okay. Well, that may have to do with that cam, because Caleb's cam was for higher RPM range than what this is.
On the 351 Windsor that we built a few weeks ago, we peaked at 261 horsepower at 4750.
Okay.
On our 350 Chevy, we're peaking at about 219 at 4,500.
Okay.
So 40 horsepower different.
Okay. That disappoints me being a Chevy guy.
Well, it is disappointing, but this is a stock cam.
Yeah.
So I just wanted to compare cam specs.
Yeah.
Because they're relatively similar strokes, similar displacement.
Similar compression.
Yeah, like both are 9-to-1 compression, so on the lower side.
They're very much alike.
Yeah, very similar motors, with the exception of the 351 Windsor was a flat tappet,
and this is it was a performance grind flat tappet,
Yeah.
whereas this is a stock
Roller.
Vortec cam.
Yeah.
So it's not what was originally in this motor, but it's still a stock
It's
cam.
for the next generation of small blocks.
Our lift on this cam is 30 thousandths shy on the exhaust and 40 thousandths shy on the intake,
Okay.
roughly. So there's less lift. Our duration is 194 on the exhaust, 191 on the intake, compared to 218 and
So-
218.
So a lot more duration on the,
Yeah, over 20, close to 20, like what, 27 on the exhaust and 20, however many that is.
Yeah.
4 on the intake. So,
but being a flat tap, it's not going to open and close the valve as aggressive as this roller is.
right. And Caleb's was on the 108 lobe separation. This is a 111 lobe separation. I guess the combination of all those things makes a difference.
Yeah. If this was our engine, it would be fun now to pull that cam out and put something similar to
Similar
what,
to-
yeah, yeah.
Yeah, put the Chevy version of that cam in here.
Yeah.
And see what it would do.
Huh.
I guess drop the comments how much difference you really think that difference. I'll post the spec differences
Yeah,
there.
post the spec difference, post what we got for results here, and then let's start an argument out there.
Does it have to do with the cam, or is it really just that Fords are that much better?
Yeah. Yeah, let's get the argument going there, and let's talk about, is it the difference between a flat tappet and a roller cam, or just the difference in our cams, or is it just Ford versus Chevy? Because obviously I'm disappointed here because I've always been a Chevy guy, and I was hoping this stock Chevy would kick the Ford's butt,
Yeah.
even though it had a little more camshaft.
Well, and when we did those first 2 runs, I thought it was gonna, because the torque is so much
Yeah.
higher in that low
Well,
range.
and that's another thing you need to point out when you make some graphs on this, is the difference of where the
where
torque.
the power band is.
Yeah. Yeah.
And his intake was for a little bit higher power band
Yeah.
too, probably.
Although, just the way it sounds and feels, I would not be at all unhappy to have that engine in my pickup.
No, it sounds good.
Yeah.
It sounds good and eliminates the issue of the flat tappet
Yes.
cam. So
Yeah.
I think what we've done here
Yeah.
should,
I think,
again, the goal with this engine was to salvage some of the money that he already spent the first time.
on all, same deal, just like Caleb's motor, but both of these had done a whole bunch of machine work and things did not go as planned.
Yeah.
So we tried to salvage on both of them everything we could. And this customer here, he did want more motor than what this is, up until the time we started talking dollars of what it'd take to do that.
Plus the whole emissions situation.
Yeah, yeah, because this has to go back in the vehicle and pass emissions.
Yeah.
Caleb's does not. He lives outside of the
Zone where.
zone for emissions.
Well, he lives outside, and even if he lived inside, with it being as old of a truck that he's putting it in, would it?
Yeah,
have
I'm
to?
not sure what the exact law is on that, but it'd be a whole lot easier to make it pass. Because this one, even if the check engine light comes on, he fails.
Yeah.
And Caleb's truck's old enough.
He doesn't have that.
No, he has none of that.
The perks of living out in the country.
Yeah, in
not
our
having-
area.
In our
anyway.
area,
Yeah.
not having to pass emissions. But
Although this guy here lives in the country too, but he's closer
closer to.
into the metropolis.
Yeah. Is Greeley a metropolis?
It is
Is that
now.
what we're calling it now? Maybe for you, because you have some perspective of what it was like 60 years ago. We're going to fire it up, and just to give it a little bit more run time to prove it to ourselves, even though
Yeah,
I think it's proved.
Yeah, I would like it pretty much fully broken in before we give it back to the customer.
So I designed a
15-minute test. It's just going to go between 3,000 and 1,500 RPM up and down for 15 minutes.
Yeah, I think that'd be great. What, about half load or?
Probably half load or
Okay.
half throttle.
Okay,
Ready?
I'm ready. Bring this down, let it idle when it's done.
Yeah, I will. It's almost done. It's going to go to 3,000. The next step was to go to 0 RPM, so
No, we didn't want to do that.
it got hot there. We almost lost a plug wire again.
Yeah, did you see it smoking or something?
Yeah, I saw it smoke.
And note to self, don't leave your timing light pickup hanging on the plug wire next to the headers when you're doing a run like that. At least not if you bought it at Harbor Freight.
Right?
Or I guess that wasn't Harbor Freight, that was Amazon, wasn't
Amazon, same difference.
it? Yeah. I think it's ready to give to the customer.
I think so too.
Send it.
And I don't see any drips on the ground
No.
anywhere or anything. I see a thunderstorm moving.
Yeah, we might want to get this broke down and back inside.
Look at all the dust over there. You see that?
I do, is that what that is?
That or a tornado.
Tornado?
I think it's ready for Braden to install.
Yep.
So that storm moved in on us.
Yeah, and we
pack up.
got done just in time and broke everything down and drug this inside, got out of the wind and dirt. Still no rain. I don't think we're going to get any rain, just wind.
Well, that was a real quick and dirty comparison of a 350 to a 60 over 350 to a 60 over 351
Yeah.
Windsor.
Both 9-to-1
Similar.
compression.
Similar stories.
Yeah.
And I'm curious, I think people should put in the comments what things they think were the biggest causes of the difference in
Yeah.
power.
Yeah.
You know, I mean, just looking at what they are and the cam and so on. But I think we're gonna wrap this one up and get it out the door.
Yep. One
It's kind
more
of
off
quick.
the list.
Kind of a quick little one that's been sitting here for way
Too
too
long.
long. Way too long.
Everything that's here has been here too long.
Yeah, but that one, this one and the 351 Windsor really had been here
Yeah.
too long. I'm excited for the next project.
Yeah.
The next complete build is kind of around the corner. Should we go give them a little
Yeah,
sneak
give 'em a little-
preview of that?
Peek at what it is.
Take us over there. And
There it is.
so what is it?
Did we say 1958 or 59? I think it was probably an early 59 because it's cast late in 58. So early 59, 348 tri-power.
Yeah.
And it is the real thing. We checked enough numbers on it to figure out that it's not a truck block with just a manifold on it. It's the real thing.
Almost looks like maybe he has. Well, I guess we don't know for sure if
Yeah,
it's been apart.
we don't know
But it looks like
anything
it
about
has
it.
the original intake. The casting numbers everywhere seem to match.
The casting numbers, dates on the block, heads, manifold all seem to match. I think this is, I would be more surprised if it had not been apart before than if it has.
But it's locked up.
But it's locked up, it will not turn. And our customer wants to build this, put in one of his hot rod cars.
So
I hope he has a very large pocketbook.
I think it's going to take it, looking at what parts cost for these.
I just hope that when we get into it, he doesn't bail out on us.
Yeah, because it'd be a fun one. I think it'd be a cool one to do for the channel.
Yeah.
And document it, because it's
But
just
it
kind
is,
of an oddball.
it is going to be expensive.
All right, stay tuned. Tear down on that coming soon.
See you later. Buy one of my shirts.
Yeah, buy one of the cleaning guys shirts.